them. So still we need to work and get more additional knowledge. This is Dr. Shelley. He is another Nobel laureate. He was the person who discovered corticotrophin releasing factors in 1977, on which he won the Nobel Prize of Physiology and Medicine. He has lots of small CRF fragments, and now we are working to deliver together with cerebrolysine using nano delivery in traumatic brain injury and Alzheimer. The results are still censored until we have approval. So we are working in many models. And this is Dr. Asia, who is leveling our drugs. She is in University of Arkansas, Fayetteville. This is one of her Society for Neuroscience presentation in 2 years ago. And since all these investigations are very expensive, you need financial support, you need political support. So this was the former Prime Minister of Sweden who helped us a lot in establishing this in Sweden. And now we are working on time release of cerebrolysine. These are titinate nanospheres produced by Dr. Asia in University of Arkansas, Fayetteville. She injects cerebrolysine inside it, and you can see that the release is slow and it's for longer time, just like mini osmotic pump. And we are using different models. So the point is, the question is always asked, what could be the possible reason that nano delivery of drugs has better effect than the novel? My answer is that still we don't know, but depending on the available data, we can tell you something, that if you inject nano-delivered drug, these are for example nanowire delivered drug, they can pierce the cell membrane with very tiny part without damaging it. We have many references available now, not ours but others. Then they can enter into the brain, this is the gut level, and then they can release either the material, the drug, here intracellularly or extracellularly. Nanowires may remain for some time. That's why it's very important to choose nanowires that are innocuous, and in University of Arkansas they are making faster recovery on knee surgery, putting nanowire level drugs inside and make it surgery. The recovery is fast, and up to 6 years, no untoward incident. So this is one of the most innocuous nanowires so far. That's why it got industrial. And so we have this nanowire review published by my wife recently. And now you know that the question of sepsis, antibiotic resistance. This is another Nobel laureate from Israel. She would like to work with us regarding nano delivery of antibiotics in severe cases of sepsis. And we are very happy that there was 10th European Shock Congress in Paris in September, and then we are able to establish neurosepsis, not known before, because sepsis, they say volumic shock and many other things. And so this was one of the sessions, consequences of shock and sepsis on brain. And I was one of the chairs together with a French guy, and then we showed some of the results where nanowire delivery of cerebrolysine can clear sepsis-induced damage. So this is one of the beginning in this area too. To summarize some of our works, this book was just published by Springer Nature in June. And this book is coming in November. This is in press by Elsevier Academy, where each chapter is discussing how nano delivery of drugs in different methods can improve brain injury. Then this nanowire delivery has attracted attention worldwide in various military organizations or different organizations. So there is one Chinese traditional medicine university in Guangzhou. They are interested that they have so many traditional Chinese medicine. They want to level this nanowire delivery. Experiments will be done in Sweden and results will be given to them, and on that basis they will try to see how their patients are improving, because they are treating with these Chinese medicine to their patients and they can see that improvement is there, but they don't know what part of it and how it works. So that's why we come in a research cooperation. This is Dr. Zhang, and he appointed both of us consultant and advisor to the traditional Chinese medicine university in Guangzhou for 4 years. And even I did not know what is written, but I just showed you. And we have just published one paper with Chinese traditional medicine, which is called DLMDT. It is a large pharmaceutical company. And we labeled with titanium dioxide nanovirus and examined in concussive head injury. We are also very pleased that Society for Neuroscience, some of you know, it has more than 13 to 15,000 abstracts are presented every year. This year in Washington. And this lady Ashia, when we did in Parkinson's disease, traumatic brain injury exacerbates Parkinson's disease neuropathology, neuroprotective effects of co-administration of titanium dioxide nanowire, Indian primary stem cells and cerebrolysine. This came hot topic of this year, and it is a big press issue. The second thing, we are also lucky that this Alzheimer's disease neuropathology is exacerbated following traumatic brain injury, neuroprotection by co-administration of nanowire medium primary stem cells and cerebrolysine. This is also another hot topic. So we are very happy that from our group, if 2 hot topics come in a year and few lectures are very rare. So this year lecture come for my son. So we are very proud that it is recognized by large scientific media. And as you know, we work harder, try to understand, but still, if we understand more, doubts will be more. If we do nothing, we understand everything is clear. But if we go in deeper, we can find that nothing is clear. So the point is that blood-brain barrier is an important part of all kinds of neurological diseases. What we have to see to deliver drugs in right perspective, effectively to control neuropathology. And probably nanomedicine, because US government is interested, US military is interested, Chinese military is interested, and some of all other organizations. So probably nanomedicine has a future. And we have large support from various world organizations. This is the Chinese Latino Hospital, Chinese Military and Science, this is the Swedish government, and many more. Of course, Uppsala University is the core support. We have many programs, many ministries are involved in supporting our work. Lots of collaborations. And I am from Uppsala University. So I thank you very much for your kind attention, and I look forward to your. Yes, please.
So I have a question. How exactly does this nanowiring method work? How invasive is it? Is there any kind of surgery on the brain?
You can inject even intraperitoneal nanowire drugs. You can even inject intravenous. Even in some cases, like traumatic injury, if you want fast relief, you can apply on the traumatized part. So it penetrates cell much quickly. Of course, if you inject in intravenous, you require some large dose because it is moving, and also some it can stop at some other place. But we have measured the brain concentration intravenously. It also goes there because the drug is released, and then this drug is going faster into the brain. Even in intraperitoneal conditions, you inject normal drug and nanowire drug. Nanowire delivery in the brain is higher in the same condition. So there must be some way it is traveling faster to the brain. That's the only thing I can tell you right now.
So some amounts of drug are distributed not in the brain but in other parts of the body.
Yeah. Until unless you are not injecting into the internal carotid artery. But internal carotid artery, it is going to one side. Okay? So intravenous is better. Otherwise, in some cases of a spinal cord injury, even we have applied topically to have higher strength in low concentration. So that saves money. And we have measured different segments, and we can find high levels of drugs are inside, even in pain. Yes?
Do you anticipate some side effects of using nanowires or
What kind of side effects?
different kinds?
For example, give one example.
For example, can some nano delivery
Absorb some kind of
yeah,
side effects.
Some?
Can you absorb some side effects?
Yes, I'm asking what side effects? Can you name one? We see no behavioral changes.
Dangerous. Something
Yeah.
dangerous.
There is two kinds of observation. One is external, the other is internal. External is that if you subject them to behavioral changes like walking on rotor and traveling on a wire mesh, we can't see any difference between the nanowire treated or saline treated animals. So we believe that external behavioral changes are not affected, of course up to certain period. We have examined only up to 3 to 6 months because that's our permission. So this period, the internal things we are concentrated only to brain, and we can see that when we have given in normal animals, okay, either topically, intravenously, up to 6 months, we don't see any neuronal changes in the brain or the spinal cord with nanowires, like any nanowires. But if we apply copper or silver, that is another case.
Thank you.
Yes.
Yeah, I appreciate you for this interesting lecture because it's lecture is very actual and interesting for our lab because neurotrauma treatment is one of the major topics in our laboratory of pharmacology. So in our laboratory we use some substances for treatment of neurotrauma. We use some lipid substances. But we don't use some special techniques for its delivery. Do you have some? Our substances have not good bioavailability. So is IO techniques admissible for the delivery of some lipid substances? Do you have some ideas?
Theoretically, yes, but I can't say until we have tested those things. For nano delivery, the substance is good if it is in liquid form. Okay? Because then we can maintain the concentration and desirable effect that how much we have loaded, how much it is released over time, and how much it can enter into the brain. So that's why even all Chinese medicines are either oil. Doesn't matter it is lipid soluble or water, but it should be in solution. That is much better. And you should know the actual amount of the drug in certain given amount of solution, like 1 milliliter. Okay? So this is possible. But a drug will work or not, it depends on the test. Yeah. Yes. Two things. We are working on this nano delivery since 2004. So this is our group's brainchild. To test our own hypothesis, we are looking for any drug from anywhere that can have some good effect. So we test our hypothesis, and people have interest, they can get results. That's why we have signed a contract with traditional Chinese medical university. They have about 5 million RMB for 3 years, and this is quite good amount. So they can send us the drug, and we level in the United States because they have the US patent. Otherwise, we have to pay a very heavy amount of money to them, and that is wastage. So it is better to work in collaboration. So then there is no direct cost to us and joint publication. So it will be leveled in the United States, come to the Sweden, and then we have a couple of labs in Europe. Then we try to do animal experiments according to the permission where we have, because in Sweden we don't have behavioral permission, but in Spain we have behavioral permission. We also have a working lab in India where we have much more freedom to do those things. You understand? So we are open to all good drug or possible good drugs to work using our model, our mode of delivery in any animal model, because that will develop and generate science. That's most important. So we are open to any suggestions or any kind of drug. No problem at all.
Well, thank you.
Okay. Thank you very much for the opportunity.
Dear colleagues, thank you so much for your talk.